Hello everybody, here we are, and finally this time we will not be facing the network issue during the day. First of all, I was live of course at noon, but at that time I was facing the network issue because of the heat of course, and I think this is the main reason behind that. By the way, here we are back, and right now I'm gonna be going. The last time I was just live for 1 hour and 20 minutes, and I was talking about the volumes. Then after that I covered this section, so right now I'm not gonna be talking about the volumes anymore, but we are gonna be talking about something else. So this is how it's gonna be going on. So without any further delay, let's simply end from tomorrow. Tomorrow, I think this Kubernetes section is gonna be over, and that's really a good thing. Today, I'm gonna be talking about the auto scaling and all. Once you have created your cluster, Kubernetes cluster, then how you will auto scale the pods or the nodes and all. We are gonna be talking about that. I hope I'm audible, and without any further delay, let's simply get started. But before even that, let me do one thing. Of course, I'm gonna be talking about all these things. Get nodes, and I have this cluster running. So what am I gonna be doing over here? I'm gonna be stopping it, and it would be a better thing. So let's see, EKS CTL delete cluster, and I have to delete a cluster, and meanwhile I have to restart a cluster. But as I'm using AWS, because there's a lot of configuration that we have to go through in AWS part. On DigitalOcean, it's quite simply straightforward. In AWS, we have to configure a lot of things. So we will be taking the help of AI to just simply know how it's done and all. And this is how we are gonna be going through the stuff. I hope it does make sense. EKSCTL, then this. I wanna delete what? I wanna delete EKS cluster. This is the name of that. And hopefully it's gonna be deleted. So this way it's gonna be deleted. Meanwhile, what I'm gonna do? I'm gonna be just simply going to the projects. And this is gonna be the learning section, and let's name it scaling this time, because of course we are gonna be talking about it. What is gonna be the duration of the live until the whatever we are going through that gets over. So time is not the issue, as I have started it, so I'm gonna be ending this. So ultimately I'm gonna be talking about the scaling over here. As this scaling, I'm gonna be just writing the whole code, creating the images and all, everything we are gonna be getting done here. Okay, so we are going to be learning about horizontal pod scaling. Before that, what all we have done, we have gone with the AGS, auto scaling groups, and where first of all we created the template. We assigned the template to auto scaling group. Then auto scaling group was responsible for creating the instances. So we have managed the instances, like how EC2 instances are managed using an auto scaling group. How auto scaling group actually scales the number of instances or downscales the number of instances. We have already gone through this. Even we have gone through ECS, that is Elastic Container Service from AWS, of course. Even over there, you had this option for auto scaling the clusters, auto scaling the nodes automatically. So, merely over there, your image gets auto scaled. So that simply means by default you will have few replicas running, and then that will be auto scaled or downscaled and all. This is how it's gonna be going on. By the way, coming back to this, here we are gonna be auto scaling the Kubernetes cluster that we have. So far, how many things we have covered? So far we have covered about the deployment, replica sets, pods, services, and especially there were 3 types of services: load balancer, cluster IP, and node port. Apart from these particular things, we have talked about SC, that stands for storage class name. Of course, I just talked about it today itself, so let me even just go through that. So if I actually go a few slides back, so here I'm going to be talking about SPA. Just the last time, let me talk about the things that I discussed. So the last time when I was live, I was talking about this particular thing, volumes ultimately over here. So we have even talked about volume, secret maps, ingress. So quite a lot of things that we have gone with. When it comes to volumes, there were 2 types of volumes. Ephemeral volumes, we have mainly had empty dir here, and empty dir is mainly used for making 2 containers share the variables, some values and all, states and all. So this is mainly for that. We have already gone through this, so we are not going to be talking about this. When it comes to persistent volume, this is the diagram that I created actually. It's pretty simple actually. You have a MongoDB database running, and /data/db, this is going to be the storage for, this is going to be the folder for storing all the information related to MongoDB database. And this is going to be mounted to NFS server, and that will be created using NFS. And inside NFS server I have a container. That a container exports Mongo folder from itself, and I'm just simply gonna be mounting to that. So ultimately this particular /db folder gets mount using NFS PVC and NFS PV. It just simply gets mounted to that, and that itself is mounted to the /data/mongo folder of the EC2 machine, and this is where the whole data just gets saved. So these are the things that we have. I just tried to create some kind of diagram. Coming back to this one, we learned about Docker Compose ML. This is just the Docker Compose file for creating the NFS server. And apart from this particular thing, we have pv.ml, how pv.ml is created for MS server. Of course, we are talking about NFS. And then similarly, we have PVC, persistent volume claim.ml file. And then a few commands that are used. And lastly, we have a normal pod that just simply starts a MongoDB pod that's going to be running, of course, inside a Kubernetes cluster. And when this runs, ultimately it just simply gets connected. What I mean over here, that this particular volume, this is the volume that this volume gets mounted to this particular folder inside the container. So it's just as simple as that. And then we have CSI PVC. The full form is maybe containers. I don't know what is the full form of CSI in Kubernetes. PVC. Let's see. So Kubernetes CSI container storage interface. So yeah, kind of we get container storage interface. So coming back to this one, better just to mention the name over here. CSI stands for container storage interface. So ultimately we get a container storage. Okay. So we can directly create a CSI.pvc. That simply means this container storage interface will be managed by the cloud provider. So here you can use GP3. You can even use the standard in the sense the node where your pod is running. Over there only your pods. If you are running a pod, MongoDB inside the pod, so inside /data/db your data gets stored. So that will be mounted to the local volume. That's what I meant. So this standard stands for the local one. So a volume will be created locally inside your particular node, and the particular local volume will be mounted to a particular folder of your project, whether that is MongoDB or PostgreSQL, whatever you are running. And when it comes to GP3, this is mainly used for creating the volume outside externally. It is mainly for AWS. DO block storage, this is for DigitalOcean. This similarly we have Volta, and we are going to be using GP3 over here because that's what we have for AWS, right? And even we have GP2, but GP2 storage, ultimately what is GP2? This is just the type of the EBS volume that you use. So GP2 is the older one, and GP3 is the modern one. So that's why we are going to be using this. And apart from this particular thing, this is just a normal pod that simply gets mounted to this particular volume. Okay. So whatever I just discussed at noon, I have just gone through that again. Coming back to this now, what are we going to be discussing right now? Right now I'm going to be discussing about HPA. The full form is of course horizontal pod auto scaling. This is the full form of it. Then we are going to be talking about node auto scaling. Lastly, we are going to be talking about the resource management as well. So this is how the things are going to be going on. Alright, continuing from here. But even before that, I hope by now it has been stopped. Where it hasn't been stopped, there is a thing that I will have to configure my EKS cluster for the R2 scaling and all. So let me talk to the AI first of all before even discussing about anything. So as per the AI, this was the question that I asked them. Correct EKS CTL cluster config R2 scaling ready. So this region fixes, okay, that's okay. So ultimately it is giving me this much. It is just simply saying that this is the configuration that you need for creating the EKS EKS cluster, and with this configuration if you create the cluster, then it will be ready for R2 scaling, because at the end of the day we have to scale the nodes as well. We can easily scale the pods, but if we want to scale the nodes, so we have to have these tags first of all. ktaste.io cluster autoscaler.enable true, and then similarly EKS cluster on autoscaler EKS cluster on. So these tags needs to be added, and I'm just creating a configuration so that everything gets done automatically. Similarly, roles, labels, they are role general, and we have IAM with add-on policies. Autoscaler is true. This is really important. Only then autoscaling is gonna be possible. So what we are doing, we are trying to create a proper configuration that will be used for autoscaling our machine automatically, so that we don't have to just do a lot of stuff manually. And then it is gonna be using T3 medium better than T3 small. Well, that's okay. I'm gonna be using T3 small right now because of course that's the for learning purpose. By default, it is just simply saying that it will have 2 nodes. Minimum capacity can be 1, maximum can be 6. Volume size, the volume size of those nodes is gonna be 20 gigabyte, and the name is gonna be for general works and all. That depends, but okay, this is how it's gonna be going on. So this is the first thing that we have to do. Overall, I have configured this. Install cluster autoscaler, mandatory. Without this, autoscaling will not occur. So the second thing that we have to do, we have to create service account, metadata, cluster autoscaler, cube system. Labels are gonna be this, EKS Amazon this. So ultimately, it is just simply asking me to do these things. And apart from this particular thing, then it is asking me to create the deployment. So first of all, it is actually asking me to create what? Install cluster autoscaler. So service account name autoscaler, cube this, labels, EKS Amazon role RN. Okay, I have to just simply add the account ID over here, and this will be sort of done. Then I have to create a deployment over here. Again, I'm just simply going through it. Look, if it were about DigitalOcean, I could have gone through the things directly, but in AWS things are different. Forget about auto scaling. First of all, you will have to configure AWS itself to just simply making it capable of auto scale. So yeah, that is why we are just simply going through these things. So deployment, cluster autoscaler, namespace, cube system, 1 replica needs to run, cluster autoscaler, template, cluster autoscaler, service name, container, cluster autoscaler. So this needs to be started. The limits 100 M. So this is the template that we have ultimately. So we have deployment over here, cluster autoscale. The name is just normal deployment, cluster autoscaler. And inside this, we want 1 replica to be running. That simply means by default there's gonna be 1 pod that will be running. And for that pod, I have app cluster autoscaler. This is the label that we have. And apart from this particular thing, spec is gonna be service account name cluster autoscaler. Container is gonna be this. Image will be used this autoscaling and all. And this will be mainly for auto scaling. It's resource limit and all these things. Replace your account. Horizontal pod scaling, I will have to ask you to just simply tell me the things in detail because I have no idea about this. Then horizontal pod autoscaler, backend HPA. Well, this does make sense. So I'm gonna be creating backend HPA that will be responsible for scaling it minimum to maximum 10. And matrix resource CPU target utilization greater than 60%. That is okay. I will be explaining it. It is understandable. Matrix server required HPA cube cuddle. I even have to do this. Final architecture is gonna be that. Well, it's quite a lot, I know, even for me. So I'm gonna be asking it. Explain everything step by step. I am a complete beginner, or it's completely new for me from scratch. Alrighty, let's see what it's gonna do. I have to just mention all the ways. Perfect. Let's go from scratch 0. What are we building? We want a system when traffic increases, more pods are created. If nodes are full, new EC2 instances nodes are created. That's what I want. When traffic decreases, pods reduce, extra nodes are removed. That's right. Simple understanding. Pod, your app container, and a node EC2 machine. Cluster, group of nodes. That's right. Going ahead, auto scaling 2 parts. HPA, pods. So HPA will be responsible for auto scaling the pods. Cluster autoscaler will be responsible for auto scaling the nodes. So we are going to be having 2 things. We will create HPA configuration that will be responsible for auto scaling the pods. We'll create a cluster auto scaler that will be responsible for auto scaling the nodes. So first of all, pods will increase auto scaled up or down. On the basis of that, nodes are gonna be increasing or decreasing. You need both, of course we need both. Install required tools, run this on your machine. So first of all, curl silent location github, what is this, ekctl release. So run this on your machine and sudo temp ekctl install kubectl. So it is asking me to install ekctl, done. It is asking me to install kubectl and AWS CLI, and luckily we have all, so we don't really need to worry about it. AWS configure, we have already configured this, so we don't need to worry about this. Let's go to the third step. Create EKS cluster, create file, nano cluster.ml. It is just simply asking me to create a cluster file. So API, this name is gonna be EKS cluster, region is this, I am with iodic IDC true, and then these are the add-ons that it is adding, and then general works, instance type is gonna be T3 medium. I'm gonna be keeping it T3 small for now, because, and desired capacity 2, minimum 1, max can be 6, okay, that's fine. Volume size 6 in the sense 6 nodes can be there maximum. So this is mainly for the configuration of the node. I am with add-ons policies, auto scaler is true, that's okay, and these are the tags that need to be added. So if I actually show this thing, what have I done? What is this? Okay, I'm just simply keeping them side by side. That's crazy. Separate. Just a minute. That was insane, whatever I did right now. Okay, coming back to this one. So what I want that let me keep these things side by side so that I can actually mention this stuff. Okay, coming back to this, I need to go to the web, and over here I mainly wanted to talk about the configuration, right? So how this configuration is done and all. So this was my main configuration, and let's see what ChatGPT actually asking me to just add and all. So now I know this, first of all, it is asking me to app, no, this is not the one. I've come far. Okay, it actually starts from here, doesn't it? Nope. Probably I was somewhere here, yeah. So first of all, EKS IO and this particular version cluster config, that's okay. I added the names and region, that's also done. With the IO this whatever the auto enabled to config false, I have added it by default from my side, that's okay. Add-ons, these are the add-ons that it is adding. Then managed groups, when it comes to the managed groups, so the name is my nodes. Name can actually be anything. Suppose it is gonna be general works, or my nodes is even better, that's okay, let it be here. So the name is gonna be my nodes. Instance type is gonna be T3 small, that I already have. It can actually be inside an array, so that's good too. So either keep it like this, or I can actually create an array and keep it like this as well, so that's interesting. And apart from this particular thing, desired capacity 16520, that's fine. And then AMI family, well, I'm not asked to add this, so that is why I will be commenting this. I will be knowing exactly what it does later. And labels, similarly, I haven't been asked to add labels, so I'm gonna be removing the labels as well from here. I will be knowing exactly what is the use of this. Then I'm asked to add tags, so required for cluster auto scaler, okay, it is enabled true on, that's it. And lastly, I haven't even been asked to add auto scaler true, or it was added here. This is added over here. I am with the add-on policies auto scaler to true. So these are the things that I have added, okay. And apart from this particular thing, then I have to create a cluster. It takes 10 to 15 minutes, that's okay. Once the cluster is created, connect it to cluster. AWS EKS, what does it mean? AWS EKS update kube config region is this, that's okay. We have another way to just simply connect it to that, but this is also one of the commands to just keep in mind. So this time I'm gonna be using this. Let's go with this one, and this is where I have to come. So ultimately what it is saying that once this is done, then once the cluster is created, /code. You can actually run this command to just simply switch the context. So let's keep it here. Coming back to this one, connect it to cluster. If you want to connect it to cluster, so at that time you can use this command. There are other ways as well. So earlier I was using other ones, so let's go with this one as well. Connect to cluster. This is mainly used for updating the cube config. What is this and all, we will be talking about this. But first of all, we have to focus on the basic things like what is the overall flow. Okay, coming back to this one, kubectl get nodes. Then I should see 2 nodes over here. That's fine. Deploy sample app. Deploying sample app. So this is the part for the sample app. So API app kind deployment, backend deployment, replicas, two replicas. I want 2 replicas in the sense 2 pods. Selector app backend, label backend, container backend, image gonna be nginx over here. That's fine. Resources, requests CPU 100 and memory 180 MI. Limits 200 to 56 MI. That's fine. That's what I actually wanted. By the way, I can go with this. What it actually does here, it is just simply saying that I'm gonna be using this particular image. Resource request in the sense minimum there should be 100 M in the sense if my CPU if I have a machine of 2 CPUs, 2 cores ultimately, so 100 M means ultimately 1000 M means 1 core. So 100 M means 0.11 CPU or something core. 1000 M means 1 core. So 100 means 0.1 part of one core. And memory I already have this much. That's fine. So let's go with this one. Limits in the sense minimum. If I want my pod to be assigned to a node. So not even pod actually. 100 CPU. Yeah, if I want my pod to be assigned to a node, so the node should have at least 100 M CPU available. If the node doesn't have that much, so that will not be assigned. At that time, cluster node auto scaling will happen. So this is the thing I will be talking about it anyway. And limits is gonna be this. So that's interesting. I have it. So what I'm gonna be doing here. The thing is that I'm not missing actually. I'm keeping everything just right here, and that will be too much for the future. So cluster is okay. I'm connecting to the cluster. Once I have connected to the cluster, that's fine. Install cluster autoscaler. So I was asked to do this thing, and storage class.pvc configuration. This was mainly for creating a PVC storage, maybe allowing AWS to letting AWS or allowing AWS to use GP3. So allow or configure AWS for GP3 EBS volume. That's what we are doing over here. So this is being done. Once this is done, then we are just simply connecting that. That's okay. And we are deleting the cluster. Just below this, I will have all the code related to the haven't I deleted that? Come on, where that is? This was the part. So just in here, I will have all the code related to what? I will have all the code related to auto scaling. So I can just simply say that most of the parts are going to be related to auto scaling over here. Again, later I'm going to be customizing it, making it a bit better. But for now, let's continue with this much auto scaling. And in here, what I'm gonna be doing first of all, when it comes to this particular ISPA horizontal part auto scaling node auto and all, so TS2. First of all, I need to make sure that I have a proper cluster. For creating the cluster, it's better to just simply keep the things inside this particular directory. That would even be better. So coming back to this, I will have a proper cluster. And what is the code of the cluster here? The code for the proper cluster is this. Again, there are a few things that I need to know, but overall this is how it's gonna be going on. So this is the code for the proper cluster. Once I have my cluster, what is the next thing that I have to do? I have to connect it to the cluster. And for connecting to the cluster, I have few lines of code here. That is this one. Using this, I will be just simply connecting to the cluster anyway, and these things I better just simply remove this. Similarly over here, this one as well, it needs to be removed, and this is how it's gonna be going on. Great. Coming back to this one, let's simply paste it here. So I have code for creating the cluster. Once the cluster is created, then the next thing is that I'm gonna be having what? I'm gonna be having sample app. That's okay. Let's go with that. So I need a sample app for this. So coming back to this one, sample app I need, so that I can just simply create a pod using that. That's great. Let's simply go with this particular one. /code. Again, the sample app code is easy to understand, so no need to no problem with that as such. Yeah, that's right. Copy it. Once it is copied, let's simply paste it over here. And simple, I'm doing nothing. I'm just simply using Nginx. The important thing is that this, whichever pod I will create, I'm specifying this resource over here. What is this resource? I will be talking about this. Resource simply says that I'm gonna be having request resource over here, and it says this thing that it has a request, it has a limit. Request in the sense, minimum there should be 100. What is the full form of 100 m full form in 100 m in Kubernetes pod. So in Kubernetes pod configuration, m in 100 m stands for milli. So specifically when you applied the CPU resource, it is refer millicores. Millicores, that is a good one. The unit allows you to specify fractional CPU resources for your containers. Yeah, that's right. So milli cores, I must say. So milli CPU or milli cores. So the minimum, the request is 100 milli cores. That simply means there should be at least 100 milli cores. 1000 milli cores means one core. Okay, and once one minimum requirement for that pod is 100 milli cores. If I don't have 100 milli cores, then of course that pod will not be created in that particular node, and then another node needs to be kind of scaled up so that the new pod can be created inside that particular node. And this is just the simple memory. What is the, and 128 mi means Control Shift T, 128 mi for memory means in Kubernetes pod specification 128 mi stands for MB bytes. Mi is a binary unit base 2, where m is a decimal unit base 10. So 128 mi is equivalent to 128 multiplied by 10 this bytes, which is exact this by comparison 128 would be approximately this one. By the way, this is MB bytes. Oh well, that's crazy name, but okay, never mind. Let's go with this. MB bytes. Okay, these are the full forms of it, and this is just normal sample app that I have that's going to be used. What is the next thing that I have to focus on? So once I have the sample app, kubectl app, we can just simply apply it, not really a big problem. Install metrics server, important. Without this, Autoscaling won't work. So I have to install metrics server. Metrics will be used for getting the metrics of the nodes and all. So ultimately I need a metrics server. Okay, so install metrics, this is important. Okay, that's great. Let me do that anyway. So let me keep it side by side somewhere here. Sample app. Then the third one is gonna be th3 to metric. What was that, by the way? Metric server. So I need to add metric server here as well. Great. Let me just simply add By the way, in DigitalOcean, it's so simple. Yeah, literally you don't have to configure anything at all. You can just simply click on create Kubernetes. Kubernetes will be created, and enable Autoscale. Autoscale will be enabled. So that's it. But okay, Autoscaling won't work. So k apply f GitHub Kubernetes science metrics server release latest download components.ml. That's fine. Then setup SPA. Okay, that's great. Not SPA, HPA. So that's okay. This is the HPA pod auto scaling. So it's easy, no problem with this. So the next one that I have, HPA pod auto scaling. As simple as that, we have it. And as for the configuration of it, it's pretty simple to understand, so no problem with this as such. This is gonna be like this, /code, paste it over here. What am I doing over here? I'm just simply saying that, bro, this is the horizontal auto pod scaler that will be responsible for scaling the pods. How will it be scaling the pods? This is the name for that. Okay, let's not worry about this. Scale target. What is the scale target? First of all, apps v1. That scale target references this API version is this. That simply means the deployment of the pod that you have. This is the API version of that. Kind is gonna be deployment. I want to auto scale or auto scale up or auto scale down the deployment. The name of the deployment is backend deployment. This is what that we want to auto scale up or auto scale down. Minimum replicas 2. By default, I still have minimum replicas 2 over there. Maximum can be 10. And what is the condition? On which particular condition it's going to be auto scaled or auto scaled up or auto scaled down? Type resources, that simply means it will be based on resource type. What is the resource? We added request and limits on the basis of that. Mainly it depends on the resource what request. And what is the resource? Name is the CPU. It is gonna be based on the CPU. Target is what? Target is the utilization. Average utilization 60. That simply means if average utilization of the pods, all the pods goes over 60%, at that time it has to what? R2 scale. But there is a condition. It depends on the request. What is the request? Request in the sense, the request that I had over here. So this is the request I have, 100 milli. So the CPU that I will have, sorry, the pods that I will have, they will have 100 milli cores. The request is 100 milli cores. That simply means pod can only be created when there is at least 100 milli core space. If that is not there, then the pod cannot be created. That simply means you need to create a new node for that particular pod. Ultimately that will be R2 scaled up. That's another case. But first of all, it is based on this particular request. Based on this particular request in the sense, the minimum CPU that it requires, that is 100 milli cores. That simply means there can be many pods, because if it is 100 milli cores and your CPU, your node is one core machine. For example, your node is one core machine and the CPU, the pod that requires minimum milli cores, that is 100. So 100 multiplied by 10, 1000, right? So there can be 10 pods inside a machine. So let me even draw proper diagrams, because this is really important. What I mean over here, that suppose this is the cluster I have, Kubernetes cluster, of course, Kubernetes cluster, and inside this Kubernetes cluster, just like this, I have a few things. Mainly I have nodes over here. So this is the first node. Similarly, I will have many nodes over here. This is the second one, this is the third one. I'm not even worried about. Suppose I have only two nodes. This is the first one and this is the second one. And when it comes to these nodes, so they are one core nodes. I can create like a node with multiple cores as well. But suppose they are one core nodes right now. So what will happen? It has one cores. That simply means 1000 milli cores. One core exactly, 1000 milli cores. So it has 1000 milli cores. And what I'm saying, inside this particular node, this is nothing but a node. So inside this particular node, what I'm saying, that I can have multiple pods running. So inside this particular node, I can have multiple pods. So I can have one pod number 1 similarly, and this pod is gonna be taking, the request is 100 milli cores, so 100 M. The minimum space that it needs to be created, that is 100 M. That simply means at the end of the day you can have what, at least 10 cores running, 10 pods running inside this. Let's keep it like this. Similarly, it will keep going on, and at the end of the day you will have 10 pods running, so it will just keep going on, and at the end you will have 10 of them running here. Simple, because one requires at least 100, that simply means 10 of them can be running. What is the how will be how will a new pod will be created? So what I'm saying, that if the CPU utilization, it has 100 M, similarly there are 10s, they have 100 M, 100 M, 100 M. That simply means if the CPU utilization reaches 100 milli cores here, that means this particular pod has reached its 100% CPU utilization. Okay, overall what is happening? Overall, as per this node, we have, let me even change the color over here. For this particular node, we have one core. That simply means once I add all the 100 milli cores, like this 100 milli core. Similarly, 10 pods are there, so 100 multiplied by 10, that is 1000. So one core is equals to 1000 milli. One core is equals to 1000 milli cores, and I'm just simply saying that one pod minimum requires 100 milli cores to just simply get created. That simply means if one pod needs 100 milli cores, then I have 1000 milli cores. That simply means there can be 10 pods that can be created inside it. Great. Now the question is, how will I be calculating the the CPU uses? For that thing, this is the top level, one course I have, and then I have 10 cores, 10 pods inside this. One pod has one pod has a request of 100 milli cores. That simply means once the pod starts running and the CPU reaches 100 milli cores, that simply means the pod has reached its 100% use. Really important. This is the most important thing over here. Inside this node you have 10 pods running, because one pod's request is minimum resource request is 100 milli cores. That simply means when this particular pod starts running and this pod starts getting the request, at that time, once, because it's a CPU resource request is what? It's a CPU resource request is 100 milli cores only. That simply means if the CPU utilization reaches 100 milli cores, that simply means it has reached 100% use. It can go even beyond that. It can be 100, 120 and all, that's okay. But if it reaches 100, because resource request is 100 milli cores, it does not mean that it cannot use more than that. This is not the limit. This is the basic request resource that you need to create the pod, and after that it can even use, you can set a limit like, okay, I mean resource request is 100, maximum it can use, the limit is 300 or something, so it can even go till 300 or something. That simply means its CPU users will be increasing to 150. So if the CPU users reaches 100, that simply means this pod has reached its 100% use, but even beyond that it can use. So it can be 100, 120, 150, even if that is set to 300 milli cores. So the pod CPU uses can actually be 300, pod CPU uses can be actually 300% as well. So that's what I meant. So ultimately what I'm saying, that this pod has only 100 milli cores. So consider it like this pod only has this much CPU for getting created, and if the CPU uses reaches 100 milli cores, that simply means it has reached 100%. That does not mean it cannot use more than that. It can use more than that, because this is the resource request that I have, the minimum thing that I need, minimum CPU that I need for this. It can use even more in the sense, for more I can set a limit. Limit can be suppose 300 milli cores. That simply means minimum I need this much 100 milli cores to create it. Maximum it can use 300 milli cores out of one core. As simple as that. So the CPU uses of this can actually be 100 if it is exactly using 100. If it is using less than this, if it is using just 50 millicores, then the CPU utilization will be 50%. If it is using 100 millicores, CPU utilization will be 100%. If it is using 150 millicores, because suppose the limit is here, suppose I am setting a limit, this is limit can be 300 millicores, just like this. So 300 M can be limit as well. It's completely up to me. Of course I can do that. So what I'm gonna say, that 100 is just the resource request, that this much resource should be there to create a pod. That does not mean pod cannot use more than that. Okay, pod can definitely use more than that, and it can, suppose the limit is 300, so it can use 300 millicores at the end of the day. So this is how it's gonna be going on. The question is, how will I be calculating the percentage, CPU percentage? I have total 1 core, and on the basis of this thing I'm gonna be checking whether I need to create a new pod inside this or somewhere else. So how will I be doing? I'm gonna be just simply getting CPU utilization of this, CPU utilization of this pod in percentage. How will I get this? Simple. If it is how will I be getting to get this CPU utilization? First of all, the CPU utilization will be calculated automatically, and you need to just simply calculate the CPU utilization. So suppose the minimum limit it has, that is minimum like resource request, that it has 100 millicore. That simply means if the CPU utilization is 50 millicores, that simply means 50% uses, 100 millicores 100% uses, 300 millicores 300% uses. So ultimately this pod's CPU utilization can actually go beyond 100. It can be 300 because the limit is 300 over here. So 300% can actually be here. So this way you will be getting the what CPU utilization. If the resource request were 200, in that case when 100 millicores is being used, that simply means only 50% is being used. 200 is being used, that simply means full is being used right now. So 100 means 50%, 200 means 100%. So it will be calculated automatically, so you don't really need to worry about it, but this is how it just simply goes. So you got the percentage of this. What is the total CPU percentage of this pod? Then similarly like this you have 10 other ones. So you have to calculate the CPU uses of all. So suppose the first one has 100% running, second one has 100% running, third one actually has 100% running, maybe one has 120% running. It could actually be this, can't it be? Let me even ask AI regarding this. Alrighty. Okay, so I have a pod, and that has been assigned a resource request, that is the 100 millicores, and that has the limit for 300 millicores. So what I'm thinking, that at the end the pod limit is 300 millicores. That simply means when it comes to the CPU uses for that just particular pod, that can actually go beyond 100, right? So when I'm actually calculating the overall CPU percentage, whether that is greater than 50 or 60% or not, so at that time I will have to calculate I will have to add the CPU percentages of all the pods inside that particular node, and then I have to divide that by probably 50% or 60% to check how many pods are actually needed, or how many pods can actually be created inside that particular node. Correct me if I'm wrong. And what I think, that pod CPU utilization, a particular pod CPU utilization, it can definitely go beyond 100 as well, because the limit is 300 millicores. Let's see. It does take some time to understand. I struggled so much today. Let's see, by the way. Ooh, you are very close, but there are few important corrections needed. Let's break it down. Request versus limit, your understanding, but refine it. Request 100 millicore CPU, minimum guaranteed CPU. That's really minimum guaranteed. At least minimum this much I need for creating a pod. Limit 300 CPU, maximum CPU the pod is allowed to use. That's right. So yes, your statement is correct. The pod can go beyond 100 millicores and use up to 300 millicore CPU. Can CPU uses go beyond 100%? Important correction. This is where your understanding needs fixing. CPU percentage meaning in Kubernetes 100%, one full CPU core. So 100 M is 10%, 300 M is 30%. So a single pod cannot exceed 100% of a single core. Yeah, it cannot exceed the 100% of a single core, but it can definitely exceed 100% of 100 M. 100% of its own configuration can't it exceed, but it can use multiple cores if allowed. A single core cannot exceed 100% of a single core, but it can use multiple cores. In your case, limit is 300, 30% of one CPU, so max can be 30%, not 100%. That's okay. So this is incorrect. Pod utilization can go beyond 100%. Correct version. It can go beyond its request 100 M, but never beyond its limit. That's right. Your idea about calculating node utilization, you said add CPU percentage of all pods and divide it by 50 or 60. This is not how Kubernetes autoscaling works. Okay, that's great. So Kubernetes actually calculates scaling. Case 1, HPA, horizontal pod autoscaler. HPA does not care about node CPU. It calculates like this. So CPU utilization is gonna be current uses divided by request multiplied by 100. So current uses 100, request is 100 M, uses is 50. So current use is 50 and request was 100. So utilization is 50%. That's what I said, yaar. So ISPA does not care about node CPU. So no, HPA does not care about node CPU. So that's what I was saying, that it I want to scale the pod. For that thing, I need the current use, whatever the current use that I have. This is the, by the way, good one that I have. So let me just simply where is that HPA. This is how CPU utilization will be used. The current uses in M millicores, request, what was the request in millicores, divided by 100, of course. So coming back to this one, if a request was 100 M, uses was 50, so 50% utilization. Great. So HPA compares uses versus request, not limit. So if request is this, uses is 150, utilization is 150%. Okay, so this is not the CPU utilization, this is just the utilization. Yes, here utilization can go beyond 100, and this is the utilization I've been talking about, because it is based on request, not limit. So your confusion is here. You mixed two different concepts, actual CPU uses and HPA utilization. So the utilization that I was talking about, that was HPA utilization, limit by 300 ml compared to the request. Okay, that's fine. Example to make it crystal clear: pod config 100, limit 300, scenario pod uses 200. In that case, actual CPU use is 20% of one core CPU. HPA utilization is 200%. That's what I wanted, but that's what I've been saying. Well, I was talking about the same thing, but in a wrong way. In a wrong way to express that thing. Your statement is statement corrected. Add okay, fine. Final summary, that's fine. Okay, got it. Uses, that's why HPA uses request, that's fine, and already understood. So this is how it just simply goes. So there are two types of things. There is a core CPU utilization, and there is something called HPA uses or HPA utilization. So ultimately I'm gonna be having two things over here. If I can see it here, actual CPU uses, actual CPU 20%, HPA is 200 utilization. That's what I wanted to talk about. Coming back to this one, so what I was just simply saying, these 100%, 100%, 200%, probably 120, probably 200, it can go up to 300, so it can be actually 300 as well. Similarly, it will go till 10 plus, suppose at the end I have this, and at the end, once I have these CPU utilizations, these are the CPU utilizations, HPA utilization, not CPA utilization, HPA utilization, and I'm gonna be dividing it by 50. So once I have the overall all the utilization, the total utilization, and at the end I'm going to divide it by 50. So what will happen, once it is divided by 50, it should be returning what? It should be returning number of pods. So just a minute, give me a moment. uh, all right, I hope it does make sense. Let's continue from here on. So what I was just simply saying over here, come on here. Okay, then let's continue. So what I was just simply saying over here, that there can be 10 CPUs, sorry, 10 pods ultimately, and when there are 10 pods, 10 pods ultimately there can be. So they, I will get a HPA CPU utilization, right? So HPA utilization, I can say utilization. So I will have HPA utilization over here, and when it comes to just a minute, give me a moment. Now I'll have to just. Alrighty, then let's continue. So what I was just simply saying over here, that seriously, yeah, sometimes things go so insane. Either I can focus on this or I can focus on something else, and I cannot focus on many things at the same time. By the way, coming back to this main point over here, whatever I was just simply discussing. So I have 10 pods over here, okay, and those pods have HPA utilization. That HPA utilization can be 50%, 100%, even till the limit that it has. That can actually be uh, yeah, in this particular, okay, what is gonna be total of it? It can be max one CPU core only. So even if I have 10 pods over here, and those 10 pods can use max 300, but at the end of the day, how much you have? You only have one core, right? So as you have only one core, so the max CPU HPA utilization, when you just simply add 100 plus 200 plus probably 50 plus probably 30 plus probably, it will just simply keep going on like this, and 10, suppose 10%. So when all these things are added, it will always be less than 1000 millicores. That is right. It will always be less than that. Okay, so I hope it does make sense. So once it is always less than 1000 millicores, so what will happen in this particular case? Uh, it is always less than 1000 millicores. So when I'm gonna be dividing it by 50, dividing it by 50 in the sense, if I divide 1000 by 50, so what will happen? 1000 divided by 50. That simply means I'm gonna be getting 10 over here. Well, 20 over here. 20. Okay, that's right. I'm gonna be getting 20 over here. So what I'm gonna be saying, few things are missing. Uh, so if I divide it, the overall CPU utilization I have, and if I divide it by 50, dividing it by 50 in the sense I'm gonna be getting around 20 over here. If that is actually equivalent to 1000, by the way, it will not be actually. So the total CPU utilization I have, missing something right now, just a minute. Uh, what can I do? Just a minute, give me a moment, I'll be right back. I have to just simply handle something. Just give me 1 minute and I'll be back. Alright everybody, so here we are, and I was just simply wondering how it can actually be created. I thought it can be created easily by dividing it by 50 or something, but still even here I will have to take the help of AI to understand. Great, but good stuff. Just a minute. So ultimately I need to know about the formula on the basis of which formula it's gonna be calculated. So what I was just thinking that total CPU utilization. So if target is 50% and when it comes to the CPU utilization, so I have 2 pods running, or suppose I have 10 pods running, I have their HPA utilization over here, and once I have their HPA utilization, that can never go beyond this. So if it can actually be less than 1000 milliseconds. So if it is actually around, suppose it is how much it is, for example 500 right now, so 50 divided by 500, so I will get 10. Simple, I'm gonna be asking the AI as only here 2. So what is the problem over here? So I'm able to get HPA utilization, and I'm able to get total CPU utilization. Now the question comes, how will the number of pods be decided? Like if the CPU utilization goes 50%, at that time a new pod should be created. Ultimately the target is 50%. So at the time, what is gonna be the formula, how or not, or whether it should be auto scaled or down scaled and all, how it's calculated? So ultimately this is the one, current pods, current utilization, target utilization. Okay, so this is the desired pods. So the real formula of HPA usage is gonna be this. So current pods, how many current pods I have? I have 10 pods. Current utilization, what is the current utilization? And target utilization. Current utilization, suppose that is full in the sense 1000. So 10 multiplied by 1000 divided by 50, something like this. So current pods, how many pods are running right now? Current utilization, average CPU uses based on request. So based on request, average CPU uses. Okay, and what you said, so for example current pods are 2, target is 50%, utilization is 80%. So in that case 2 multiplied by 80 divided by 50, that's gonna be 3.2 rounded up to 4 pods. So HPA will scale from 2 to 4. Okay, this is fine. So ultimately this is the rule that's gonna be used over here. So let me do one thing, I'll have to copy this particular rule as well. On the basis of this particular rule it is calculated. So copy, and interesting, I'm gonna be pasting this over here. So this is all about HPA, how the pods are gonna be calculated. Slash code, just, well, that's insane. Okay, copy it, and hopefully I can just simply paste it here. So coming back to this one, delete, probably try to paste it. Well, this is insane, but this does make sense. Coming back to this, desired current pod, target divided by what is the overall rule over here? Just a minute, give me a second. Slash code, desired pods are gonna be current pods. So let me take a screenshot of it, that would be the best thing. Done. And coming back to this particular thing over here. So ultimately I'm able to get the CPU utilization. CPU utilization is gonna be current uses in milli and the request. Just a minute. What was the CPU utilization thing? CPU utilization, so current use in millicores. So what is the current use? And a request in millicores. So what was the request? Multiplied by 100. So this way I'm gonna be getting CPU utilization. So if current uses in milliseconds, millicores, what is the current divided by what was the request okay, it's just simply blowing my mind right now. Alrighty, so I have desired ports, that's gonna be current ports, that's okay, I have that. Current utilization and target utilization. Target utilization I already know. What target utilization? How to get target utilization is that's great. Current utilization, how am I supposed to be getting that? How to get everything, like current ports I already know, and current utilization and target utilization, what are they and how they are calculated. Whew. Let's get everything here. The main focus was on getting it done anyhow. Well, even this is taking time, but yeah, understanding is the most important thing. Directly cannot copy and paste. So current replicas command get a deployment, your deployment. If I have 3 by 3, so my current ports are 3, that's okay. Current utilization from HPA config, kubectl get HPA 50%. So this is gonna be the, so here 50% is the target utilization, that's right, and you define this in ML, that's fine, and current CPU utilization percentage 50%, and get HPA 60-50, so 60% is the current. So this much is being used right now. And what is this actually? This is my HPA. My HPA is calculating the, okay, that's great, but how is this being calculated? This 60%, how is this 60% being calculated here? So utilization is gonna be actual CPU. Okay, so formula for current utilization. So actual CPU uses, as to how much is being used. Yeah, that's fine. This is what I wanted, because until unless I'm able to do it on my own, it doesn't really matter. Come on, yeah. Here it is. So two things I need to keep in mind. Copy it. I should be able to calculate everything on my own, and then I'm gonna be getting things done. Paste it over here. Okay, so utilization, CPU utilization. So ultimately I'm gonna be getting the utilization, and once I got the utilization in the sense current utilization, so actual CPU utilization divided by CPU request multiplied by 100, I will be knowing more about it, and ultimately this is gonna be the current one, and then this is how it's going to be calculated. Let's see. So seeing in the sense, suppose I have it like this in the sense, I have 10 pods running over here. When 10 pods are running, even though the limit is 300 millicores, but at the end, max to max, it can only reach one core. That simply means 1000 millicores. So suppose when I have 10 ports, I wanna calculate HPA utilization. So 100, 200, 50, 30, and similarly it keeps going on like this. And suppose at the end it is around 1000 millicores. That simply means total 1000 millicore is being used. And once total 1000 millicore is being used, so what I'm gonna be saying, current utilization, because target, suppose target utilization is how much? 50% over here. And now the question is, if target utilization is 50% and all the cores are actually being used, that simply means 1000 millicores, at that time what is gonna be the current utilization? Current utilization, what is the rule for that? The rule is pretty simple. That is gonna be actual CPU uses divided by CPU request, that is actually 100 in our case, and that is 1000 divided by 100, that simply means 10 multiplied by 100, that actually becomes 1000. So utilization is actually 1000, that simply means 1000 millicores are being used. That does make sense here, by the way. Actual CPU uses, what is the actual CPU uses? For now I consider that the CPU uses is actually 100 millicores, because we are playing with the cores right now. So that is actually it is in percentage, so I have calculated it. Actual CPU uses. Now the question comes, how will I calculate the actual CPU uses? Okay, let's do one thing. I think I should be going through it really well. Current okay, let's current replicas. Okay, got the current replicas. 3 replicas are there. Current utilization from HPA config. That's okay. So 60 by 50. So the target is 50. 60% is being used. That simply means it should be scaling up. 50% target utilization. You defined this in ML. That's right. Current utilization very important. So get HPA. So 60. So 60 is the current utilization that we have. But how this 60% is calculated? This is the most important part. So formula for current utilization. HPA uses actual CPU uses divided by CPU request multiplied by this. So example per pod. So suppose request is 100 M, that's right. Actual uses 70 M. Then 70 divided by 100 multiplied by 100. That's gonna be 70%. That's right. That's actually gonna be 70%. And for multiple pods important, so for multiple pods 50, that's gonna be 50%, 100, that's gonna be 100%. So average is gonna be so current utilization is gonna be 75%. Average, got it. And once I have the current utilization, keep total pods, so 70, 50, 100. Uses request, got it, understandable. The thing is that the thing that I've been missing over here, that's been this, that I got the utilization in the sense CPU HPA utilization, then I have to get the average CPU utilization, and that's gonna be the current utilization, and that's what have been calculated over here. So current utilization, that's gonna be the average, so average across all pods. So ultimately average CPU utilization is actually gonna be current CPU current utilization that simply means average across all pods. Okay, let's try to just simply go through it. So when it comes to CPU utilization, so I can get the CPU utilization like this. So suppose let me have an example here, a proper example, and how it's gonna be. Suppose I have two pods, and when it comes to those two pods, so actual CPU uses, one is using around the limit, the request. When it comes to the request, so what is the request over here? The request is 100 M over here, and pod number 1 is using around 70 M, or pod probably 71. Pod number 2 is actually using around suppose 150, because the request is 100 and limit is actually 300 or something. So if I have 3 pods over here, so it is actually using around this much, and pod number 3, that is actually using how much, suppose 200 M. So this much they are using. And when it comes to CPU utilization, so actual CPU uses, what is the actual CPU uses? 70. So 70 divided by CPU uses 100 multiplied by this whole thing actually, and once it is divided multiplied by 100, so it is gonna be 70%. So this is gonna be 70%. 150, so 150, this is gonna be 150%, and similarly this is gonna be 200%. So these are the average CPU these are the HPA utilizations and once I have these utilizations, after that what I can get actually average CPU utilization. So here average CPU utilization, that's gonna be equals to how much is being used on an average. So at that time, for calculating this, what I'm gonna be doing, I have this much, so 70 plus 150 plus 200 divided by 3, because I have 3 parts over here. So that's gonna be 200, 350 and 70, 420 divided by 30, divided by 3. So that's gonna be around ultimately 420 divided by 3, if I'm not wrong. 200, 300 and 370 plus 5 20, yeah. And if I just simply calculate this, so that's gonna be 112.140 or something. Let me see. 1 gone, 2 came. How much it's gonna be going to be? Let me just simply calculate this. 4 1 4, 3 1 3, and 1 12, 3 4 12, and 0. That simply means around 140. So 0 4 3 12, 1 3 1 3 and 4. Yeah, that's right. It was 140. So I got 140 over here. Once I have 140, so this is what? This is the CPU utilization as per the example what was given here. 50 100, I had 150, so 75%. So current utilization was 75%. If I divided by 50, but this pod CPU utilization can actually be more than that. And if it can actually be more than that, so it can even go beyond 100. So current utilization can actually go beyond 100. That's right. So where does actual CPU users come from? So actual CPU users can actually go beyond 100. That's fine. So where does the request come from? This 100 full flow end to end. You've got all this HPA rates. Okay. This CPU utilization that I get, it can actually go beyond 100, can't it? This CPU utilization can definitely go beyond 100 as well if the pods are going up to, like using up to the limit, right? Good catch. This is where many people get confused, and let's clear it. Yes, HPA CPU utilization can go beyond 100%, but only because it's calculated using request, not limit. Why this happens? HPA is gonna be CPU uses and CPU request. CPU, what is the total your example, request 100 milliseconds, limit 300. Now suppose pod is using 200 M CPU, so actual CPU is gonna be 220% of one core. HPA utilization 200 divided by 100 multiplied by cancel 200%. So yeah, so HPA sees 200% utilization. Important distinction. Actual CPU uses node capacity, HPA utilization request, yes. So statement is correct. HPA utilization can go to up to 300%. Example with limit 100, 200, 300. But one more important thing, even if limit is 300, a pod cannot exceed 300. HPA utilization max gonna be 300% in your case. Final understanding. So yeah, it can definitely be 300. So ultimately whatever we have got here, that's correct. So we have calculated this much. So at the end we got 140%. Okay, average CPU utilization. And once I have got 140, that is the current one, how am I gonna be getting the, once I have this much, then I'm gonna be calculating the pods, right? So pods are gonna be equals to current pods, that's gonna be 3 I have multiplied by current utilization, that's gonna be 140 divided by target is actually 50 suppose, or probably, yeah, let's keep it 50. If the CPU utilization goes more than 60%, then, and or it's better to make it 70, 72 and 3 to just 6 pods can be there more. 6 more pods can be created, as simple as that. So these are the number of pods that can actually be created inside that particular what inside that particular node. Let's see, give it to the chat GPT and see whether this is right or not. You're very close, but and this is actually correct thinking. Just couple of small refinements and you are understanding this perfectly like Kubernetes does. Okay, great. So your inputs pods are gonna be 3, request is 100 millisecond, target is 70%. Okay, pod 1 70%, pod 2 150 and pod 3 is 200 millisecond. These individual utilizations are correct. Average utilization you did this 150, correct. That's great. 140% I got. HPA formula desired pods is gonna be did this. So apply this, I got 600% correct. Final result. HPA will scale. HPA has 3. It can scale up to 6 pods. So small but important real world nodes. Rounding. Kubernetes uses seal round up. It's already 6, no issue. So it won't jump instantly in cluster. It may gradually 3 to 5, 5 to 6 due to stabilization and window policies. Limits are relevant here, even though pod 3 200M close to 300 limit. HPA does not care about limit at all. One more inside very important, look at your system. Target is 70%, actual average is 140%. That simply means each pod is handling 2 or more load than expected. So you need 2 multiplied by pods. That's why 6 pods. Perfect mental model. You nailed it. Oh, thank you. Alright, so ultimately this is how the pods are created. So there can be as per the load right now, because it can be actually each I have only 3 models, 3 pods, and what is actually happening over here, the average CPU utilization is 140. That simply means they are handling twice the load they should be handling, and that is why I need to have 6 pods, and for having 6 pods it is gonna be just simply scaling. And at last what will happen, when will the node will be auto scaled? When will the node be auto scaled here? Now you are asking the missing piece. When do nodes scale? HPA pod scaling, cluster auto scaler nodes scaling. Short answer, nodes scale only when pods cannot be scheduled. So in your example 3 6 you calculated 3 pods, you calculated 3 to 6 pods. Now the question is, can the current node fit 6 pods or not? So a node has enough capacity. So suppose a node capacity is 1000 CPU 1 core, each pod requests 100 mm. So max pods per node can be 10 pods. So you need only 6. Result, all 6 pods fit on the same node, no need scaling. Case 2, node does not have enough capacity. So node capacity is 400 M, each pod requests 100. So suppose node capacity is 400 M, each pod requested this much. Max pods per node is gonna be 4 pods, but HPA wants 6 pods. That's right. In this particular case, what will happen? 4 pods are gonna be running, 2 pods are gonna be pending. This is the trigger. When the pods are running in pending state due to insufficient resources, then the cluster autoscaler wakes up. What does what cluster autoscaler does? Detects pods are unscheduled, checks can adding a node fix this. If yes, adds a new node. New node is gonna be added. After a new node is added, pending pods get scheduled, system becomes healthy again. Important rule must remember, node scaling is not based on CPU percentage. Node scaling is based on unscheduled pods. That's right. Copy, probably copy, and at least concept is getting clearer. Once the overall concept is clear, then I will get the remaining things done as well. Alrighty, this particular thing is done. Full flow end-to-end load increase, CPU utilization rises 6 to blah blah blah. Okay, whatever. Calm down. Let's continue. So this particular thing is done. Set up HPA pod and apply. We can just simply apply it. What if so we have gone through this setup. HPA is also done. We have even calculated everything on our own, so that's a good thing. So we know how this is calculated, how it's calculated. Ultimately what will happen over here, that it will return me the total HPA utilization. Once I got the total HPA utilization, then I'm gonna be getting average HPA utilization over here. Once I got the average, after that what will I be doing? Pods, number of pods is actually gonna be equals to whatever the current one that I have, suppose it is around 500 or something, divided by 100. So whatever I had, I think it's what is the rule? Divided by 50, actually not 100. And at the end of the day, I'm gonna be multiplying it by 100. I hope this was the rule. Let me have a look at the rule right now. HPA, the last rule that I had, desired pods, current pods, I needed the number of current pods. Okay, that's great. So for calculating the desired pods, first of all I got the CPU utilization. After that I got the average CPU utilization. By the way, this is the HPA utilization. Then average. Once I got the average, to get the current, I one current divided by target. Okay, great. So over here, not like this. Suppose I have, how many CPUs I have? I have 10 CPUs already, and those 10 CPUs are using around 700 or something. Suppose, just for example, 700%, and so 10 multiplied by, come on, 700, and the whole thing is gonna be divided by suppose 50 or something. If it goes over 50%, so it will tell me the number of CPUs that I have. So 100 multiplied by 700 divided by this, so 2 multiplied by 700, 1400. 6 total pods. First of all, it needs to be divided, right? So let me divide it. So total percentage was 700, so 750, 55. So 5 multiplied by the way, this should be 10, yeah, come on, like this. So once this is done, so 0 by 0 gone, or and I remained 5 over here. So 5 to the 10, and what? This gone, this gone, and 700 divided by 5. So 700 divided by 5, that's actually gonna be equals to 70. 5 10 50, 11 5 55, 12 5 60, and 13. So okay, let's calculate it like this. 1, and ultimately 20 remained. So 5 4 20, 14 5 70, 70 or something. Alrighty, so ultimately I will need 14 140 pods. Just a minute, how are the pods going to be calculated here? Earlier what was I doing? That I had 3 pods running, simple, and when I had 3 pods running, so the average CPU utilization, when I calculated and divided by 3, so at that time it was around 140 or something. Got it? So this time what is gonna happen? Okay, I calculated it. So suppose I had it like this, and then total CPU utilization that I had, that was around 700, right? 700%. But I have to get the average in the sense divided by 10 pods were already there. So ultimately 70% it was being used. So all the CPUs were being used 70%. Got it? And once they are being used 70%, at that time I'm gonna be calculating the number of pods. That's gonna be equals to 10 multiplied by 70 divided by 50, just like this. So 50 से this gayo 5 2 are 10, so it will become 2, and 2 multiplied by 7, that's gonna be 14. So for the current load I need 14 pods. But do I have 14 pods? Not really, I have only 10 pods. So 4 pods need to be created. So now whenever scheduler will try to schedule add 4 pods in the node, it will see there are already 10 pods. That simply means the current one cannot get more than 10. So it will create a new pod. By the way, the current current node that I have, by the way, I need 14 one, but current only can handle 10 nodes. That simply means 4 nodes are gonna be 4 pods are gonna be unscheduled. So a new node will be created, and those 4 pods are gonna be scheduled over there. So this is how it's gonna be going on. Whoa, we have done it, yeah. Literally, we've done it. So this is the overall theory part. Even I myself was confused, and that is why I just simply wanted to go through each and every step. So step set up HPA pod auto scaling, and once this is done, by the way, HPA we have already saved it, right? Yeah, 60%. So HPA is already done. What is the next step? Once we have gone through this, so what happened now? Install cluster autoscaler node scaling. So create a file like this. So we have to have a file like autoscaler.ml. We have to have this, right? Autoscaler. So install cluster autoscaler node scaling. Create a file autoscaler.ml. So let me do that. Okay. Auto node autoscaler. This will be responsible for creating scaling the node. And what is the file name? Autoscaler.ml. Autoscaler, just like this. Coming back to this one, /code, copy it from here, paste it over here, and deployment. This is the deployment that I am creating. Name is gonna be cluster auto cube. Size is gonna be 1. Selector match labels cluster auto scaler apps cluster container is gonna be this. This is gonna be the image that will be used, and cluster auto scaler. These are gonna be the commands. Cloud provider AWS node is gonna be this. General works. This is the node general works. What is this? This is the deployment that I have created. Not deployment. This is something that I have created. This is the name of the nodes. Yeah. So that is the general works. And by the way, I have actually named it my nodes, if I'm not wrong. So coming back to this one, inside the cluster, the name of this node was my nodes. So I have to just simply change the value from here as well, my nodes. So ultimately it gets the value of the nodes. So cluster autoscaler and cloud provider AWS nodes is gonna be 1 by 1 to 6. It is just simply saying that the nodes can be minimum 1, maximum 6, and the name of the node is gonna be my nodes. As simple as that. Pretty simple. I mean, the name of the node group is my nodes. And once this thing is done, of course I have to apply it. Test auto scaling. So try run loader generator image busybox. Kubectl run, and I'm gonna run this loader generator image busybox bin ssh, and while true, what will this do? While true, do inside this particular one, I have to run this particular command. Do we get a http backend services. So ultimately it will be making a request to backend service that I have created, and done. So this is where it will be sending the request, and this is how it's gonna be going on. So what you will see: CPU increases, HPA creates more pods, nodes get full, creates cluster auto scaling, adds new instances, final traffic, CPU utilization goes, HPA pods, nodes full, cluster auto scaler. Common beginner mistakes: forgetting matrix server, not adding this. Finally, by the way, I get a copy this. This is really a good stuff. I will see how it works. This particular thing. Test. How am I gonna be testing it? For testing it, I'm gonna be using busybox over here. And for using the busybox, if I run this, this will be opened, and I'm gonna be running this particular command inside the busybox. I'm gonna be executing that, right? So this thing is done. And lastly, I have testing. So for testing this, code, and I'm gonna be pasting it here. And lastly, what I need to run, once I run this, I'm gonna be seeing exactly how it works and why it works, most importantly. Not just like it works, we will be even seeing the reason behind it, but overall this particular thing is done. So all the steps we have here, whatever we had to go through, now we have to just simply go through each and everything one by one and see whatever we have here, does it actually work or not. One thing that I wanted to show to this what is the use of AMI, Amazon family, and does it even required, I mean, is it required for, are these required for cluster configuration? Let's see. Short answer, no, they are not required, but they can be useful depending on your use case. Let's break it down. AMI family, Amazon Linux. So what it does, this tells AKS which OS image to use for worker nodes, Amazon Linux 2. Is it required? Not required, because AKS automatically uses the default AMI, usually Amazon Linux 2. When should you use it? Use it when you want to explicitly control OS. You switch to something like Ubuntu or something. Recommendation for beginners, default setup, you can skip it. Labels, what it is, labels are used to tag nodes, so labels, role, worker. So is it required? Not required. Cluster will work perfectly without it. Why it is useful? Labels help in pod scheduling, very important. You can tell pods node scheduler, role, worker, and pod runs only on specific nodes. Okay, advanced setup, separate front end, back end nodes, GPU nodes, but you should use labels since you are learning EKS Autoscaling. Use labels if you want to experiment with scheduling, you want to control where pods go. Otherwise, you can skip it for now. Fine. Keep config minimum, just like this. Okay, fine. So let me give it the whole config that I have. Okay, copy it. Let me give it for the last time. Is this right for the learning purpose, or there's anything I need to change? Your config actually good for learning. You already included everything, that's great. So what you did, right? Things to improve. You wrote T3 small format. You wrote this. This is not correct for managed node groups. So in that case, I have to just simply edit like this. That's great. Desired capacity carefully. You have to. This is fine, but remember, cluster autoscaler works within 1 to 5. So you are good at here. And SSH optional, but useful in learning. So allow. If you want to debug debugging cases, so allow SSH helps in when you want to inspect nodes, debug scheduling issues and all. So SSH is gonna be allowed. So add labels optional, helps you test node selector scheduling concepts. Add capacity, very capacity on demand, default is on demand but explicitly better. CloudWatch cluster, okay, I mean it can be definitely better, there can be more things. It is just simply, let's add it, I mean why not. Let's see how many things it has given me here. So just simply add, the better the better. It doesn't really matter. So this in auto config enabled this. I have added these things, capacity type on demand. What labels I know about this, SSH, just simply SSH into the machine, and these things are completely optional. Let me know more about a few things here. First one is enable CloudWatch logging for better logging. So CloudWatch cluster enable types, is this added here? CloudWatch not really added actually, great. Apart from this particular thing, capacity type very useful in AWS. Capacity type on demand, default is on demand but explicit is better. Later you can try spot cost optimization. Okay, fine, it can actually be spot as well. Yes, POT, yeah. So later I can explore something called spot here as well. Okay, and there is something called labels. I already know, recommended for learning. Labels, role worker helps you test a node selector scheduling concepts and all, that's fine. And helps I have a such optional but useful for learning if you want to debug access for debugging. So okay, let me have few comments here for the scheduling just for the learning purpose. Similarly, I have to debug. These are the things I have to explore more. So whatever comments I have, that simply means I have to do more about it and how it's used and all. It's not compulsory to add them. I'm gonna be just removing them. At least right now I'm gonna be removing them. And this is how overall things are gonna be going on. So without any further delay, let's get going. What that's been already a lot of delay, but here we've been just simply learning the concept, right? So now let's see whether it actually works in action or not. Alrighty, so close this. These are the steps that we have to go through. First of all, this is the file that we have. Copy this. This is gonna be what, backend deployment, not this one, yeah, the cluster that we need. So copy it from here, and once we have it here, so I'm actually gonna be coming here. It has already been installed. Okay, let's simply close this. ls, and when it comes to the scaling, so vi and eks cluster.ml, paste it over here, save it here, and let's change a few things if they are required. And once I am here, so at the end of the day, I'm gonna be just removing these things from here. Not quite required for now. This is how I'm gonna be going ahead, and overall it should be working fine. I'm gonna be taking a break here. Why break? Because it's gonna take some time to just simply create it. And ls, if I just simply say eks ctl create cluster, file is gonna be eks. It is gonna be just simply taking around 10 minutes or something. So let me take a break. Once it is created, I'll be back, and I'll actually continue from here on, and we will just simply go through all these steps, simple step. But again, this particular process is gonna be just a bit time taking, so I'm just simply gonna be taking a break here. Once it is done, I'll be back and continue from here. Until then, take care, and I'm gonna be catching up soon.